Okay, this doesn't have the page number, but this is going to be 80B. So this is 2 pages that are stapled together. Ratios and rates and tables and graphs. So we have the information that for every toy ball that Nathan buys, he gets 2 free stickers. So for every toy ball, so we're looking at 1 ball, he gets 2 stickers. Now we're going to write that ratio, which we just did. We're going to make a table, and so that for 1 ball, he's going to get 2 stickers. We're going to find out that if we continue this, we can figure up to how many stickers for 5 balls. So we multiply this times 2. 2 times 2 is going to make me 4. Times 2 is 6. Times 2 is 8. And times 2 is 10. So our rule is that we're multiplying by 2 to find that number. Now we're going to list the ordered pairs, and the number of balls is X, and the number of stickers is Y. So our first ordered pair is a 1, 2. The second ordered pair is 2, 4. The next one is going to be 3, 6, 4, 8, and 5, 10. So we have these ordered pair that now we're going to put on a coordinate plane. But to do that, we need to label. So at the bottom, we're going to put the balls. And then on the side, we're going to put the stickers. On a coordinate plane, we're always going to have this as 0, 0. So then we're going to count over. We have 1, 2, 3, 4, and 5. We only have to go up to 5. It could continue 6, 7, 8, 9, and 10. Going up, instead of putting all those numbers next to it, I think I'm going to count by 2s. So if this is 0, this would be 1. I'm just going to skip every other. That would be 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so now I'm going to graph the ordered pairs that I came up with. The first one is 1, 2. Next one is 2, 4. Next one is 3, 6. Next one is 4, 8. And 5, 10. And so I can see that I have this line that's being created showing that there is that proportional relationship. Now, there's a new ratio. It says, if Nathan received 40 stickers, how many balls did he purchase? So we're going to set up the relationship that we know you get 1 ball, 2 stickers. And for the number of balls he purchased, we don't know. We're going to make that X, and the stickers are going to be 40. So there's a couple of ways to do this. To find this number easily, we can see that the relationship, if I went and took this and multiplied by 20, I could do the same thing here, and I would get an answer of 20, because 1 times 20 is 20. So X could equal 20. The other thing I could do is use the cross products that we talked about in class, because we know this is a proportion, and we know 2 times X would be a 2X. And then if I multiply 40 times 1, it would be 40. And so then I could set up that 2X equals 40. Notice it says to solve for X. And if I'm solving for X, I want to isolate X to compute and do the same operation to both sides. So because it's multiplication, the inverse of that is division. I divide both sides by 2, and X would give me 20 that way. So I could get the answer either way. Now we're going to look at some ratio tables that have been set up. Okay. And on this side, keeping in mind what we know about ratios, we want to go through and practice slashing the trash. So what I would like you to do is carefully read each problem, highlight the important information, and then go through and slash the trash. Don't go through and look for the answer. Look and try to identify those that are not the answer, so that we can see what's left to be the answer, and then we can talk about that. So for each one, highlight the important information. I'll help you do that right now. And then you're going to stop the video and see if you can go back and slash the ones that don't make sense. So Rachel's riding a train to her aunt's house. The train travels at a constant rate of 55 miles per hour. Which table represents the relationship between H, the number of hours Rachel travels, and D, the distance she travels over a certain length of time? So we know that this is a 55 miles per hour. Okay, and so that's going to be helpful in identifying ones that do not work, and then to help us to find the one that does work as far as a ratio table that fits this word problem. Number 2, it says a brownie recipe requires 4 cups of sugar and 3 tablespoons of vanilla. If the recipe is reduced, which proportion can be used to find the number of tablespoons of vanilla needed if 1 5/10 cups of sugar are used? So our ratio is we have 4 cups of sugar, 3 tablespoons of vanilla. We know that we're trying to figure out vanilla, which is V, but we also have 1 5/10 cups of sugar. So we're trying to set up a proportion so we can find that missing amount. So when you look at number 2, make sure that the information you know is included in your proportion. And finally, for number 3, it says, to make purple paint, Tia mixes 8 cups of blue paint to every 5 cups of red paint. Which table shows possible values of R, the number of cups of red paint, that Tia uses, and B, the number of cups of blue paint? So we know in our ratio we have to have 8 cups of blue paint, 5 cups of red paint, because we're trying to make purple. We're going to keep that in mind as we look at the ratio tables to see which ones work. So I'm going to pause the video. You are going to go through and slash the trash, the ones that don't make sense for that, and then we'll come back and see if we agree. Okay, looking at what we know, if it's 55 miles per hour, I'm looking for 1 hour and 55 miles. I can see there are 2 that do not make that or meet that requirement because I have 1 hour 45 miles. That is not going to work for the problem that I have. The other one that's not going to work is I'm not traveling 2 hours in 55 miles. I'm only doing 1, so I know this one cannot work. So that allows me to get rid of those 2. Now, looking very carefully at what I have left, I need to figure out which one doesn't work out of the 2 that we have here. So I notice on this that have 1 to 4 is going to be a times 4. But 55 times 4 is not going to be 110. If I were to just think of 50 and I had 4 50s, that's 200. And this is going to be more than that. So I can reason that this is not going to work because it has not changed using that same scale factor. And in this case, it's multiplying by 4 here, so I would have to multiply by 4 here. If we look at this one, we can see that to go from 1 to 3 is times 3. 55 times 3 is 165. I go back to the original. If I have 1, I can multiply by 5 to get 5. 55 times 5 is 275. That's why A is the answer. For the next one, I'm going to slash some trash. I see that I have a different amount of sugar for vanilla. But if I look at this ratio that's set up here, it says 4 to 4. That would mean that I would have the same amount of both ingredients, that it's an equal ratio that's a 1 to 1. That doesn't work at either A or B. If I look carefully at the next one, I can see that 2 to 3 does not match my numbers of 4 to 3. So that's not going to work. But when I look at this one, I'm a little concerned because I have the 3 first and the 4 second. So I want to see what the quantities are representing. I know that 4 is sugar, so I'm going to put sugar on the bottom. And I know that the 3 is supposed to be the vanilla. If I look carefully, I see that the 1 5/10 is with the sugar. So both of these are in that same line, and so that works. And both of these are representing vanilla. So I will be able to use this one to figure out the amount of vanilla that I need if I change the recipe to only being 1.5 cups. For the next one, I have 8 cups of blue paint, 5 cups of red paint. First thing I see is that A has the numbers backwards, and I have to have the same order. So for this one, because blue has to be 8, I know it's not going to be A. Looking at this very carefully, I see something that looks very strange on C. I see that I have it 8 to 5, but then 5 to 8, not going to flip around. That doesn't work. So that is not going to work because I can't change those numbers. I cannot change 8 to a smaller number and then 5 to a bigger number by multiplying both by the same. So that brings us down to these 2. And I notice that the first 2 columns, the first 2 ratios are exactly the same. So now I'm going to focus on the ones that I have here. So if I look at 8 to 24, I could do times 3. And then 5 times 3 is 15. I can multiply to get 32 times 4, and 5 times 4 is 20. So it looks like this one would work. Let me look at this next one. I know that this is the same. So if I look at 8 to 32 is times 4, 5 to 20 is times 4. Well, that looks okay. But then if I go from 8 to 64 is times 8, 5 times 8 is not 25. That's times 5. So I can't have two different numbers. It has to be the same scale factor for both to keep it a proportion. So D does not work. This is going to be glued into your interactive notebook on page 80B. So you're just going to glue on the back to get that put in.